Hello, everybody. So today I'm continuing my broadcast on the programming of a BMP encoder in C first, and then in Python. Um, so where we left off, we had just finished the basic definition of the BMP image, and now we are concerned with drawing pixels and drawing lines, right? Which is really easy because on a BMP picture, that's just basically, at least on a 24-bit BMP image, that's just a matter of placing 3 bytes somewhere in the photo. Uh, Now, earlier today, I was going for a walk and I had realized my girlfriend had asked me a question about how all this works because she was watching it, interesting enough. And I realized there's an error in my code, right? So BMP images for the scan lines, aka the rows, need to fall on a 4-byte boundary, and my code actually doesn't exactly do that because I forgot that each pixel is not 1 byte. Instead, each pixel is actually 3 bytes, right? Because there's the RGB, or in this case, the BGR, because they're backwards for whatever reason on BMP. Um, And so this area of code actually is right here, right? Actually, I want to maximize this because for right now, the other thing is not relevant. So in this area of code here, um, it's doing this, right? So I figured out that there's a little trick to quickly determine if the number is only 4. The problem is it shouldn't be that it's the width. It should actually be instead 3 times the width because um, the width is just how many bytes there are, right? Is how many pixels there are, right? But if each pixel is 3 bytes, then it's not, you don't just check if, for example, the width, let's say it's 50, is divisible by 4. It's not. Um, it would be a the 150 bytes, which again still doesn't fall in the right boundary, but it's not helpful, right? So earlier I was 1 second, let me just switch to a different screen. Okay, so earlier I was doing this little scratch pad thing where I determined that um, I can use a bit mask where I just check basically, um, yeah, whether these 2 bits are on, right? And in hex that gives me the this 0x3, right? Because these are the bits that contribute a problem when dividing by 4. The problem is, so if you have a 50, an image is 50 wide, so 50, uh, 4 divides 50 is not true, right? But that's assuming that we have 51 byte pixels, but we don't. We have 53 byte pixels, right? So the actual side is 150 uh, bytes, right? And I can't just say, oh, it doesn't matter, because sometimes maybe the width is I don't know if I don't know if I can just infer that multiplying it by 3 doesn't matter because it'll never fit. Let's just go and let's test that right now. So yeah, let's do a little Python programming, right? Okay, so let's see. I'm just gonna make a table, right? And I already know that 0, 1, 2, and 3 are not going to fall on a 4-byte boundary, but I'm just going to go ahead and do it anyway, right? So what I'll do is let's just go all the way up to like just for the gag of it, let's go up to like 150 pixels, right? Okay, so now a row in the table will be I, right? Will be I times 3, and whether or not the former two are divisible by 4, right? So eh, I divided by 4. I want it to be integer division. I mean, it'll always be because all these numbers are discrete anyway, but just to be more direct. So whether or not I divided by 4 is equal to 0, right? Or, oh, no, that's not true. I'm tweaking out. If the modulus, right? Okay, so now let's just go ahead and see what we got for, let's just go iterate over the table. So, I'm interested in seeing like, let's go all the way up to 24 examples, right? Let's actually do 25, so I know 24 falls on a 4 byte boundary, right? Let's see if they always agree. Okay, yeah, I mean, they always agree. I think if a number was not divisible by 4, multiplying it by 3 wasn't going to suddenly make it divisible by 4 anyway. So I don't think that's an error in the code actually. It's just that the particular amount of bytes additional in padding it needs, the calculation should be different, I think, right? Because yeah, so it didn't need this math is weird. The way I'm doing it right now determines how many extra pixels it needs, not how many extra bytes it needs, right? So then I need to actually multiply how many extra pixels it needs by 3. That's the problem, right? Let me see if that's captured in the code. Let me see. Oh, Okay, we're back. Somebody knocked on my door. Anyway, so during that time, I was just continuing some of this. So yeah, there's agreement here between this idea of uh, multiplying by three has no effect on the thing, but the difference is that we're using different units of measurement, and we don't care about pixels, we care about bytes, right? Um, so I think the problem is more that let me just continue doing it on the scratchpad, right? To convey the idea before I adjust the code. So the erroneous thought is but we don't really want to think about pixels because pixels are like an abstraction, right? Pixels are just what we call it every time those 3 bytes are together for the 24-bit RGB. So it's just weird to think about it in this term, and especially because the subsequent memory allocation or the subsequent field that gets set is not in terms of pixels. That's not the unit it's using. It's using bytes, right? The file size in bytes. So instead, if we do width in bytes, that would be the width times 3, which would be 150 pixels, right? Um, and in this case, again, we would need, if we needed 2 more pixels, and in this case, we need each pixel is 3 bytes, we would need 156, which would say we need 6 more bytes, right? Um, because what? 156 is 140, uh, which is obviously divisible by 4, I believe. I don't know. Let's see. Uh, I don't know if BC um, handles modulus, right? Yeah, so 156 divisible by 4, right? Let's use Python again. Just I like using Python as a calculator, honestly. Okay, so yeah, is there a specifically what's I want to see what the quotient is. 39, right? So there would be a I don't know. Anyway, that's how much padding would have to be added, right? So yeah, I think it would be probably good to keep track of that additional state, right? Um, and obviously we're not going to write every well, I guess we do write every field. But it's weird because you write all of the struct to the file except for the pixel data, which is, so I don't think I'm going to care about there being additional memory because we're not going to write the whole struct to memory anyway when we do a file because you can't. It's not just going to write. It's going to write the memory address of the pointer. It's not going to write its contents, right? Um, I believe that's what I think happens. Uh, anyway, so another thing I realized is I don't really think there needs to be this needs to return a pointer at all. I think this needs to return nothing. Or maybe it can return like true or false, right? Or like some status code, right? Um, so actually, I'll put it, I'll put like easy BMP status, right? Um, because I think it makes more sense to just put the BMP on the stack memory, not in heap memory. There's no point putting it in heap memory because just that there's no, it's not a big struct, and it's going to, the pointer is going to, the data for all the pixels is going to be a pointer to heap memory anyway. So it's just kind of like we have all these things on the heap, and it just doesn't make any sense, right? And like, how many BMPs will we possibly be using where you have to, um, you know, worry about overflowing the stack by putting this relatively small struct on the stack? I just think it doesn't make any sense. It'll be faster if we put it on the stack. And it makes more sense, I think. So this is going to now take instead a pointer to the BMP, right? And it's just going to set the BMP, right? So now what we do is we're going to check, for example, if the BMP pointer is null, right? Okay, so my script for changing my system's theme ran. So let me exit out of Vim and then just go back in. Yeah, so Vim doesn't adjust properly to the color scheme when that happens, but I just exit out, right? Okay, so actually I had this code right here already. So I'll just paste that, right? Oh, what? Okay, cool. But now the message is different, right? Okay, dope. All right, I just don't know what I'm doing today, I guess. All right, anyway, so then another thing too is that the dimensions have to be appropriate, so no zero height, no zero width. Uh, and this obviously goes away because we're not going to allocate the memory. And now, so for this area, I'm not going to be using the pointer operator for the with the arrow. Now I'm going to be using dot, right? So BMP arrow needs to get replaced with BMP dot, right? And I'll apply that on all occurrences within the area I've selected, right? Okay, cool. So now the compiler shouldn't give me a problem about that, right? All right, so now, um, now the way this works is I count how many bytes over the 4 byte alignment is. So not under, but over for the previous, right? So this is because we're always adding more, not subtracting bytes, right? So we care about reaching the nearest greatest 4 byte boundary, right? Um, but now what I want is 3 times the width, right? Eh, let's see. Yeah, 3 times the width, and that gets masked, right? Okay, so this is where I'm going to store the additional uh field, right? Because what I want to keep track of now is how many bytes of padding are needed for each scan line, right? But I think this equation is getting a little bit just kind of ugly. Uh, it was clear when I wrote it, but right now it's kind of a little bit like, what the hell was I doing, right? Um, and since I made a new enum, let me go ahead and put that on here as well too, right? So, uh, easy BNB status, right? Okay, so I guess 0 should be the good one, right? So let's put status failed, I guess. So maybe I can put, yeah, let's just put that, right? All right. Now since I actually don't remember, so I think, what is this? This is 4 bytes, 4 bytes, 4 bytes, 8 bytes. So this is oh wait, no, this is 1 byte. This is 2 bytes, right? So this is 14 bytes total, which doesn't fall on the things. Just gonna add some padding. So maybe what I'll do just to make sure this thing doesn't need any additional padding is I'll put unsigned short over here, right? Just so it falls on a 4 byte boundary. And what I'll put then is yeah, what am I gonna do? I'm gonna put a padding for scan line, right? Um, this will be in bytes, right? And that field will get filled. Yeah, that field will get filled when I'm doing all the calculation to see if the thing, so I can determine the file size, right? Oh, my internet connection just dropped down really badly. I wonder why. It's not fading away either. I'm starting to drop a lot of frames. Hmm. I wonder what's happening. Okay, the stream is back. I don't know what just happened. I just started losing a ton of uh, bandwidth or something. I just started dropping a bunch of frames. I don't know why. I'm looking at my network usage analyzer. Just fucking spiked way high um, at some point, but whatever. Okay, anyway. Um, yeah. So I think by doing this, it also will fall on a 4 byte boundary, right? Okay, so what I see is four fours basically. Now, just I think they say to put um, these at the top. I don't know if it matters. I don't think it's an add any extra padding. I'll have to check on that later. I'm not gonna derail the stream with that right now. Anyway, yeah, so this is 16 bytes, right? That's how many bytes these are all using, right? In which case we have a trailing of 4, 8. And although I think I already know this should end up being 40, I believe. Yeah, so 40 bytes. So now we're rocking 56 bytes, right? Let me go ahead and drop 8 bytes for another 8 byte, right? Yeah, because this is a pointer, so 8 bytes, right? Um, which puts us at 56 plus 8, so 64. So the next number divisible by 4 to have it fall on a 4 byte boundary would be I just add another 4, right? I think what is 68 divided by 4 should be 10 plus so it's 17, right? So that's true. So I'm at freedom to add uh, another whatever, I guess. All right. So, and now let me go ahead and modify this, right? So this doesn't return a struct anymore. This returns a pointer struct. This returns a yeah, returns this enum, and this also expects a BMP pointer, right? Okay, cool. So now the headers all match just fine, right? And what I can do is, so by default, I will say that by default, I'll say it's equal to 0, right? Um, right. So this is the case where it wasn't 0, right? Because this would be some other number. If it's not over a 4 byte alignment, then it's nothing, right? So what we'll do is the amount over would be so actually, yeah, it's still 54 because we ignore um okay, so here I had this somewhere, right? This guy. Um this is 14 bytes. I added another guy, but we're not going to write it to the file because it's not important. And then this guy is here. Uh and this guy would be here, but I'm using a 24-bit BMP, so this doesn't have to be there, right? So that's where the 54 comes from. Then it's yeah, the width plus 4. Okay, cool. Um I think I get it. It's just kind of a little bit out of it today. Okay, so the padding per scan line needs to be um okay, so we're gonna add 4, so it falls at a number that's divisible by 4, right? So the width plus 4 minus the amount over the 4 byte alignment, right? Um, this is probably a better word for this, so I think it'd be more like eh, pixels over. That's still kind of bad. Um, okay, I think that's the best I can muster. So pixels over previous alignment, right? And now we're just going to continue using the width, right? That's fine. and that's the pixel thing. Then I'll update with this padding per scan line, right? So then it would be um 3 times this whole thing, right? And now this is a different word, right? So this would be yeah, and this, right? Pixels over the previous alignment. So 4 minus pixels over the previous alignment, right? So what I do is, let's say it was 50, which is nothing to do by 4. Um, then it would be 50 plus 4 minus, and 50 would be how much over, right? Um, 48, right? 48 would be the newest, the previous alignment, right? Minus 2, right? Which will be 50 plus 2, which will be 52, right? That's how many pixels. Um, They multiply that by 3, which would be 156, right? Oh, no, that's not the amount of padding. Hmm. Okay, so I think what I need more is I need more like I need pixels, uh I need bytes per scan line, right? Or uh basically bytes without padding, right? This could be big but not super big, I think, right? No, if it gets whatever, I'll use a size T, right? Bytes per scan line without padding, right? Is this the way to do this? Okay, Jesus Christ. I think I just want this to be in bytes. I don't. This pixel shit is stupid, right? So what I'm going to do then is I'm going to say, yeah, let's say, okay, so at first this will be without considering the padding, right? And that will be 3 times the width, right? Now what I'll do is I'll do width in bytes, right? Um, and the padding per scan line will be the width in bytes. Okay, so now this would be now this represents the amount of bytes over the previous alignment, right? Okay, so in which case the padding I would require per scan line, that's actually irrelevant, right? We don't no, that's still important, right? That would be basically okay. So let's say I had the width in bytes, right? So the width in bytes would be 150. The problem is I needed that to be more like 156, right? Um, the bytes over the previous alignment would be. Oh, my mind is not even in this. I should like I'm getting distracted. 'Cause I'm not even thinking about this properly. I'm thinking about something else. Um, I have 150 bytes, right? Which is 2 bytes over, right? So what I'll do is I'll add 4 so that it would fall in a 4 byte boundary minus how much over it was, right? So I take the width in bytes plus 4 bytes again minus bytes over. Okay, yeah. So it's the same math I was doing previously. It's just that the units are different, but the name so the names are okay. Whatever, fine. All right. Um, so that would just be 4 minus bytes over previous alignment, right? Um, I'm gonna add another number, right? So then it will be yeah. No, I'm just gonna directly set the width. I think I need to keep track of that, but I'm trying to figure out how to do that. Okay, so then it would be 54 um, plus okay, how I'm gonna do this. The width is the width without padding. Then you use the padding to consult that every time. Actually, no, I want to be more explicit, right? So I need to add this member, and this member is already here. Um, yeah. Okay, 1 second. I have to go answer the door. Okay, I'm back. I think having a second away helped me clear my mind a bit. I'm just getting a lot of text on my phone, and I'm thinking about that more so than the programming. So anyway, what I determined is I want to add a couple extra fields. I'm gonna add them to the bottom, and if it causes the struct to not fall on a 8 byte boundary, I'm just going to adjust it later, right? Okay, so here are the things I want, right? So I already have the width, and as far as I understand, the width. Whoa, okay. Why is the mic like maxing out on volume? Okay, so since I already have the width, right? Let's turn down the mic's gain a little bit. One thing I do want though is okay, so I want the width in bytes, right? Um, because that's more for implementation. This is more about like something else entirely, right? Because um, the padding is like hidden away from you. This is talking about like the abstraction, like how in terms like when it gets rendered, how the person sees it, ignoring the padding, right? The padding, this is like presentation. This is like implementation, right? So the things I want to aid myself in terms of implementation would be the width in bytes without padding, because I don't care about pixels, right? Fuck pixels. I care about bytes, right? I know that once I write 3 bytes, I've written some pixels, right? So then I want width in bytes with padding. And just because, it's not like a whole, it's not like I'm using a lot of memory in this case. I don't want to have to do the division, not division. I don't want to do the subtraction. It would be fast, but I just don't. I just think it's silly to every time I want to reference the padding, this thing I calculated, why not just save it, right? So then I want padding per scan line, right? Cool. So the width in bytes could potentially be very large. So I'm just going to put that as a size t, right? And of course, if that's potentially very large, then this other value will be potentially very large, even though, um, yeah. And then the padding per scan line, right? Padding per scan line is never going to be a whole lot. Just make it more explicit, right? Padding per scan line in bytes, right? That will never be a lot of bytes, because it's modulus 4. So this can actually just be a uint 8t. I just don't want to add additional padding, so I have to see how that's gonna work out, right? But yeah. So the width of the picture can be an unsigned 32-bit integer, but it's going to get in terms of bytes, that gets multiplied by 3, which potentially puts us outside the area. So we want to use a bigger number, which in this case is size t for 64-bit integers, and for 64-bit computers, and for 32-bit computers, there's actually nothing. We just have to hope that there's no overflow, right? Okay, so I'm going to modify the header, right? I'm just going to mess up all of this, but I don't care. Okay, so let's say again. So what I wanted was and now this would be with padding, right? Um, and then so up there I had added padding per scan line in bytes, right? So actually, that doesn't cause a problem at all. This is 8 byte boundary. This is 8 byte boundary. This is 8 byte boundary. So that's a okay. All right. So all in all, the struct is maybe about like something like 64, 70 bytes, whatever. But that's not really all that bad, I think, for all this information. And then yeah, this is over here. Cool. I just want to change this though. To make it more explicit. And they fucked up that thing up here, but I don't care. This comment is no longer necessary, so see, maybe I can push everything over here. Yeah, stuff starts getting messed up, but that's okay. Uh, that's fine. Just make sure you view it in maximized window, I guess. All right. Of course, then that means I need to change my init function. Well, that's what I'm already doing, right? So that's this guy, right? And I'm setting these already. So width is already inherited. Um, yeah, over here I just set the width over here, right? So now what I want to do is determine the file size, right? Okay, so first, well, there's a subactivity, right? And that subactivity is determine how much padding is required, right? First, I'm going to set it to 0 in case that it doesn't have to go into this area. And I'm just going to, yeah, I'm going to erase this. I'm going to erase this. Let's just do that again, right? So the width in bytes, um, without padding is that, right? And this is a member of the BMP, so I can just set that directly there. So the width in bytes, uh, with padding then is going to be without padding, uh, modulus this guy, right? Because maybe that gives me, yeah, so actually, no, so I think I'm doing this a little bit out of order, right? So the BMP dot, uh, padding per scan line in bytes, right? That will be equal to, uh, without padding, right? Modulus this. So that's how many bytes over it is the previous 4 byte alignment, right? Um, and so you would add 4 and then subtract how many over it was, right? So that's how much padding it needs. So for example, um, if I have 30 bytes width, right? Because it's only width 10, right? Mod 0x3, right? It should be, well, why don't we ask Python? Okay, so yeah, it would be 2, right? Um, so it's 2 over, so we need to add 2 more bytes, right? That way it's at 32 bytes, right? So uh, this equals 2. So 4 minus is equal to 4 minus 2, which equals 2. And that's again how many bytes we need to add, right? So yeah, we have 4 minus this, right? And then the width in bytes with padding would just simply be the BMP within bytes without padding plus um, the padding per scan line in bytes, right? There we go. Now we finally have all that stuff, right? So you can just delete that, right? And this guy gets set. Now I don't need to do a conditional, I think, right? Because I've already set the values directly. So I can just calculate based on the width in bytes with padding, which actually just ends up being the same thing as the width in bytes without padding, if padding is unnecessary. So now I don't have to add this branch, which is really cool because the branch is quite slow on the CPU, right? Okay, so if we have yeah, um so then BMP dot, I think I called it file size, right? That would be 54 bytes from the header and the info header, plus the width with padding times the height, right? Because we have that many um, rows of that width in bytes, right? And so it's just stacked up so much time. So it would just be times the height thing that we get, right? Cool. I believe that works. And I set this guy, all these things. Yeah, and then I allocate its memory buffer, right? Which is its file size minus 54 because we don't care about all the metadata. We just care about how much data we said that we need. And then say if it's null, then we figure out allocate memory for it, and then we don't return a pointer anymore. Now we return status okay. All right. I think otherwise, probably we'd want to return like status failed here because something went wrong. Now you can't free the BMP because the BMP is dynamically allocated memory, so that's okay. Fix that. Cool. Okay, so I think that function has been fixed, right? No. All right. Just had to clear my mind a bit. All right, so now we're doing pixels, right? So I'm gonna skip this one. Actually, this is at an offset. I'm gonna do it the coordinate instead. That sounds a bit more fun. Also, just easier to do. So I believe this returned the offset from where it returned the offset for the next available pixel, right? Okay, so I want to put a pixel at a coordinate, right? So now pixel data is already on the stack, so there's no point to redoing that by encapsulating it in some sort of like pixel struct or whatever the hell, right? Um, so let's see. Well, first, the row and the column have to make sense, right? Uh, so the row can't be greater than the height, right? Because as we like put it at row number oh well honestly this is not row and column. This is like XY, right? Yeah, well, you're putting out like an XY coordinate, right? Okay, so there's obviously problems, right? So there's no negative coordinates, but that's okay because it's not possible because this expects an unsigned integer in the first place, right? Um, I don't remember. I think it said like rows start upside down or something, right? So I have to like, I don't know if I need to do some weird math for that. Yeah, scan lines are stored bottom to top instead of top to bottom, right? Um, I don't know for the sake of my implementation if I want to. Uh, so I guess instead I'm gonna say fuck XY, right? I'm gonna say this is gonna be the scan line you want to put it at. Um, and actually I'm going to enforce that ruling, right? I'm gonna say I'm gonna continue. So yeah, scan lines are stored bottom to top instead of top to bottom, right? Um, and since the uh, somebody's playing like bad music outside, just kind of distracted me. Sorry. The bits per pixel field. Okay, that's this guy, right? 24. Okay, yeah, so that's just the thing I was doing. Need you up control. Yeah. Okay. Each scan line is zero padded to the nearest 4 byte boundary. If the image has a width identified by 4, say 21 bytes, yeah, I get that. And then they're stored bottom to top, top to bottom. So maybe I want a function to like get a scan line, right? That's probably something I need to do because based on the scan line, I want to go ahead and get where the scan line begins, right? So that would be a character pointer, I believe, right? No, so I'm not using character and unsigned character. I'm using right now. I'm using uint 8t, right? So sort of return a pointer to a uint 8t, right? This would be BMP get scan line, right? And once again, I'm going to copy this citation just so I'm going to print this code later. 'Cause I need to take it with me somewhere. Let's see. Okay. One sec. Let me let my girlfriend in. Okay, I am back. I let my girlfriend in. They were talking about how her day at work was and all that, hugging and kissing. Okay, so yeah, I'm gonna just go ahead and I'm gonna try to like do this scan line function, and I'm probably gonna end up the stream, right? And then I'll probably eh, I think tomorrow I'm going to stream again, maybe after work. So uh, I was checking to make sure that my stream wasn't having audio problems on my phone. I forgot it went off. Hashtag embarrassing, right? Yeah, because for a lot of the past streams there were like weird audio problems. I don't know if it has to do with just like the computer getting overwhelmed, whatever it is. Anyway, let's go ahead and finish this, right? So the scan line, right? And the scan line is start from top to bottom. Now it's unsigned, but of course the scan line can't be greater than the height, right? And in fact, since the height is counted in human numbers, not starting from zero, it has to be if the scan line is greater than or equal to the height, yeah, then I need to return null, and I need to print a warning, right? And let's see. So yeah, right. Yeah. Okay. So that's the error case, right? And additionally, the BMP can't be null, right? What the hell is that? Hmm. So then additionally, okay, so all we do is eh, basically it's a matter of let's see, I probably need to draw this out. This is more like kind of visual understanding thing. So we're referencing the pixel data, of course, right? Is where we begin. So pixel data itself is equal to the first byte of the first pixel in the first scan line, or actually reality in the bottom scan line, since the image is stored bottom to top, right? Hello, Niraj. Did I say it correctly? Welcome to the stream. All right, so let me just go ahead and make this a little bit smaller because it's this is not like a visual thing right now so much. Okay, so then if Uh, this would be the last byte of the final pixel in the first scan line. Okay. Um, so similarly, if I wanted to go to the subsequent scan line, right, I would go to with padding, right? That would bring me to the first byte of the first pixel in the second scan line from the bottom. Okay, so in other words, it's really just the scan line times um, the width in bytes with padding, right? So in other words, this would be if I wanted scan line one, aka the second scan line from the bottom, then I would do one times BMP width in bytes, for which is really just this guy, right? Similarly, this is the same thing as zero times BMP dot width in bytes with padding, I think, right? So what I want to return would be uh the scan line would begin at BMP dot. Oh wait, why did I change all this to the dot operator? This is still the hour operator. I still have to return the BMP. Okay, yeah, so I need to go change that later. I was tweaking out. I don't know what the hell I was talking about. That would be when you're accessing it from the main function that uses the library. Okay, so now what I'm going to do is BMP pixel data, right? I'm going to index it via. Oh, okay. So this one needs to be. Yeah, this needs to be scanline pointer, right? Um, so it'd be scanline times BMP with um in bytes with padding, right? But this actually gives me, yeah, not this wouldn't give me the pointer, right? So actually I need to add these together. That's a memory address, right? Cool. And that would be the memory address, I believe. Then I can return scanline pointer, right? Okay, so now I need to copy this um, function as it needs to appear here, right? And I need to modify this once again so that it's using the hour operator and not the dot operator. That was incorrect of me. Okay, so it didn't compile. Yeah, so because I still have return null, I can't return null from the entity to return code, right? So this means the return status failed, right? Oh yeah, height is undefined because height is not a stacked parameter on the function. Height instead is a member of the BMP. Oh yeah. There's a pointer, right? So okay, I compiled. Okay, so then I have yeah, easy bmp.c. I'm just gonna write like one little pixel, right? So actually, what I'm going ahead and do is I'm gonna say I want a uh, super tiny picture, right? Um, and code 0 is all right. So this is kind of a silly. I needed to have moved status okay to some other value, but okay. So if I try to init and there's a problem, then I'm just gonna go ahead and do this, right? Um, and I'll say failed to init instead of failed to allocate. I can't really test that this works or not, right? Okay, whatever. So anyway, I want the second scan line. All right, let's just go ahead and do that. Which would be the top scan line, actually, of the picture, right? So, and since I'm not really doing anything here, this is a very basic test. I just want to print what the actual value was. So, since it's a 2 by 2 picture, the pixel data starts over there, and then 8 bytes later is the address, right? So it's 2 by 2, so it's 6 bytes, right? And then 2 bytes of padding, right? So 8 bytes later, yeah. So that actually checks out. So the scanline function works, which is cool. So now I can use that as a helper function when I'm doing the place pixel. at a coordinate, right? First I'll get the scan line address, and then it's just a very simple offset of that. So that's really cool. But I'm going to end the live stream now. That's going to be for tomorrow to continue with that. I'll start drawing lines and placing pixels at coordinates. So yeah, thank you for watching.